walk in and we realize that we have classmates who are out, you should tell me that I should be recording. And if I'm not, like, you should clue me into that. So for our friends who are home, you've missed a few minutes, but that's totally fine. These are the announcements. Read them. I'm going to move on. I don't need to read them for you. We talked about this. And that is right here in our notes. And this was a problem from Khan Academy, so if it's still an issue for you, we should probably talk about it. But the biggest trick was not trying to find a point at a value of 10/7, but instead follow the proportional relationship until we find something better, like 70/7 is 10. We just now have started talking about this problem that's slightly worse, because the change in y goes by 1, and the change in x is not as friendly, and we'd rather have the change in x be 1. And I made a little math mistake right about here, which is why we're scribbling over things. And we were just in the process of counting up to, this should be 10 right here, because that would be 130 tenths. So just like we got 70/7, we know that we were going up by 13 tenths. Do that 10 times and you'll get to 130 tenths. And that would be the point 1310, right? So remember, our points are ordered pairs, are written in x, y ordered pair form. So it'd be 13, 10. We said one point that we want to use with proportional relationships is we always have the 0, 0 point. So then if we were to go to graph this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. So we would drop our point at 13. No, sorry, is it 10, 13, 13, 10? Crap! That's in the wrong place. Ignore what I wrote in black. 1310. Remembering this is our x-axis, this is our y-axis. We would really want arrows on the ends of these. We show the origin point. We connect our points. Now, the thing about proportional relationships that some of us will have already figured out, depending on how much you've already done in Con, is proportional relationships will always be written in the form y equals something times x. And that something, m, is often the letter that we use for it. You can remember it by saying multiplier in your head if you want, since it multiplies by x. But m is often referred to, well, not often referred to, it is. It's our slope. So m, the multiplier in the equation, is this delta y over delta x. Now, this is why we talk about proportional relationships before we talk about linear equations. A proportional relationship is a linear equation, but a linear equation that is not proportional, and we may have talked about this just briefly, will have a number. So another number added or subtracted out here makes it not proportional. Yeah, when there's a y-intercept. So in this case, when we said, okay, well, delta y over delta x, if I go and make what we call the slope triangle, I can see the change in y and the change in x. To go from this point, I might as well full screen. Yeah, it didn't change much. To go from this point to this point, we can make a triangle. And actually, we can make it either way. I can go up and then over, or over then up. Some people like to do this because we go rise and then run. But our rise here, we went up 10, right? We went to a y of 10. Rise over run. Rise over run. I am sorry, that is wrong. I mean, you can draw it this way, but when we talk about the math, it's going to be rise over run. It's going to be the change in y over the change in x. So if we talk about the slope in this case being change in y over change in x, the change in y was 10, the change in x was 13. So the equation for this line, no, y was 10. Remember, this is why we said this one was kind of messed up. All right, guys. If you're in that gray space of confusion, put your pencil down and listen for a second. The reason that this one is behaving differently than the other ones is x was changing by the awkward amount, y was changing by ones. So, to get up to a nicer set of numbers, like 13, 10, we had to go through 10 iterations or 10 additions or whatever you want to say of 1.3 being added to the x. That made our x 13. Our y at that point is 10. It's okay if you had them backwards, but x is 13, y is 10. So then, if we put this point out here, go out 13 on the x, go up 10 on the y. So we go up 10 over 13, or we could say we go over 13 and then up 10. Order doesn't matter, but when we divide, order matters. So delta y over delta x, or change in y over change in x, is 10 over 13, making our equation of the line y equals 10/13 x. Yeah.
What's the line on the x-axis that is the little, like the line that doesn't connect to the thing? What is
Line on the x-axis.
this? Yeah. What is this?
That's just 10. I just marked 10.
Oh, okay.
Sorry, I should write. Yeah, I should write 10 there. So yeah, guys, your y over x and your x over y, they will be reciprocals of each other if you set it up like backwards by accident. What's up, Ivan? Can you what? Oh, yeah, that's fine. Electric sharpener's up here. You don't really have to ask to do that, man. Just try to get through people's space quickly. So, guys, that's a tougher one. I'm not going to lie, that's a tougher one. Let's try to step it back and look at a couple other examples. They're different, so probably. So let's talk about a situation like this. So it says, graph the line that represents a proportional relationship between D and T with the property that an increase of 3 units in T corresponds to an increase of 4 units in D. Then it asks us for what is the unit rate of change when D respective to T. That is 1 change in T. So let's go ahead and when we set up this table, let's put T first. I can't get a single sheet of graph paper. That's all I need. Okay. We're going to take multiple. Right? For no reason, also. Like, why am I so frustrated? All right, T and D. So we're going to put T first, D second. So, guys, remember that I post these videos. You can go back and watch them if you, like, remember. Wait, we did this in class, but I can't remember how to do it. So, like, now that I am recording, this will be posted.
Are they on your Schoology page or what?
On the YouTube page. My YouTube link is on Schoology. What all you have to do is go to go to the YouTube and then. All right. Right. So Audrey told us that a proportional relationship will have the point 0, 0. That is super convenient. And if you haven't been starting there, you've been making these problems more difficult than they need to be. They tell us that an increase of 3 units to the t, okay, t goes up by 3, makes an increase of 4 units to the d. So likewise, if we got 3 more to 6, we got 4 more to 8, got 3 more to 9, got 4 more to 12. Right, and we could keep going. Then it asks us, what is the rate of change of d with respect to t? This is where this problem is confusing. What I want you guys to be looking out for when you answer problems like this is what one gets a change of 1. What we want, if you want to make a little note, what we want is a change of x, quote unquote. Normally we talk in xy, but we're not talking xy here. But what we want is a change of x to be 1 or 10 or something that can turn into 1 easily. So when they tell us when t changes 1, when they say 1 unit in t, that tells us t is our x. When the problem says 1 unit in t, that tells us t is our x, because we want x to be 1. It makes life easier. So if we set up change in y over change in x, well, that's really change in d over change in t. Are you with me? / who's confused how I got this jumble of letters? Hold on. All right, what now?
I mean, it makes sense, but it's still like practice more.
So, what I was debating if we had time to get into today, and then I'll take more questions, is what slope actually is. Slope is truly the change in the dependent over the change in the independent. And normally, like in just standard math situations, normally y depends on x. For example, when y is height and x is time. Or when y is like distance and x is time. Oh, wait. When y is distance and x is time. If we're talking about time, it's almost always the x. Because, guys, time doesn't care about you. Do you think the clock is waiting for Logan to be like, all right, it's 3 o'clock now, you can go ahead?
Yes, I do. I was that one that does.
Obviously, Logan needs some mental help, so we will get you somebody to deal with your time delusion.
I prefer that it wasn't like burlap or anything for the fake.
Burlap? Not that, well, okay. If Logan thinks he controls time, so unless unless Logan is Doctor Strange, I'm thinking that you don't control time, right? Time is independent. If you've ever heard the statement of time waits for no man, that's a like, I forget what book it's in, but time is independent. Time doesn't ask you, can I move on? But height, I can't just grow taller. Logan can't be like, I'm going to grow 2 inches right now. Like, oh, you can say that. You are right. You can say that. Okay, Logan, do that. Once you grow 2 inches, you can talk again, okay? So, that is not true. You would be on 2-inch lifts. You would not have grown 2 inches. You'd be standing 2 inches taller. You would not have grown 2 inches. But guys, the idea I'm trying to get across, I don't want to take a bajillion what ifs, is normally when we graph things, what we will see is something that we're talking about is the y-axis compared to time or something else that we don't control. So our standard graphing puts an independent variable down here. Yeah, no, that's spelled right. Our independent variable down here, and our dependent variable. So, like, when I plant tomatoes, I can't just make them grow taller, but they will grow taller as time moves on. Right? Height is dependent to time. So if I come back up here to actually answer the question, all I got to do is put my d value over my t value. So when d changes 4, t changes 3. Ah, man. We get 4/3. That's our answer. Now, the equation, if it's normally y equals the slope times x, well, what's our y here? We said y is like our d, right? Y is like our d. So we'll say d is equal to our slope, 4/3, times what's our x here? Our t. Yeah, don't do that now. Yeah, now you see where that gets real bad. I know, from the beginning. I know, I agree. Go back and change it. Guys, here, sorry to interrupt people, but I have very little time. Here's why we use slope like a fraction, and why changing this into a decimal would be really, really silly. Because normally people are like, well, and that's 1.3 repeating. Yes, but don't do that. Because if I come down here, and I say, okay, we said our independent variable in this case was time.